Okay, so now we will start. Okay, so just I simply share my screen. So today is our third number of class on Google Earth Engine for remote sensing analysis, and we'll already cover our first day and second day. So let's go our today's class. So I simply share my screen. Okay, so now can you see my screen?
Yes, it's appeared for me. Thank you very much.
Okay, let's go. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So today is our third number of class, and today third day's course content will be that. First of all, I will try to discuss about that how you can easily filtering and displaying the satellite images, mainly Sentinel-2. And previous class, we also try to discuss about the Landsat images, how you can easily filter the Landsat images. So today I also try to discuss about the Sentinel-2 satellite images, how you can easily filter, and after that, how we can easily monitor the NDWI or normalize different water index. So mainly normalize different water index. It's identify the water on the surface. We also try to identify the water on the surface using the NDWI using the satellite image Sentinel-2. After that, how we can easily make the NDVI time series chart, different time period, what is the condition of the NDVI. We also try to make the temporal chart and also observe when the NDVI is the high, when the NDVI is the low. This type of analysis we can also try to show you that. Then how you can easily export any shape file from the Google Earth Engine platform. We also try to discuss about this part. And then calculating any indices from satellite images. You can get the satellite images and calculate any types of indices. It can be NDVI, it can be NDWIs, it can be SAVI, NDBI. So any types of indices, how you can easily calculate. We also try to discuss about that. And then how to add the gradient legend on your map, and how you can easily do for the LST monitoring, land surface temperature monitoring for your surface, and how to calculate NDWI from MODIS and Landsat data. So let's go. So filtering and visualizing the satellite images in Google Earth Engine platform. So mainly when you want to filter the satellite images, it mainly depend on your sum factor. And previous day, I also try to discuss about the factor. First of all, your region of interest. Suppose I want to need this satellite image for the Dhaka city or any region. Which region you want to need, you can simply import the boundary shape file of your region and you can easily get that. And then you have image metadata. Suppose I want to need this image, which image will be not more than 1% cloud cover. So this is the other factor. And third factor is that I need these satellite images only for the year of 2017. So using the same factor in this time, we also try to complete filter the Sentinel-2 image collection and display the result. And after that, we also try to make the NDWI map from the satellite images. So let's go. I just simply open my code editor and try to show you all of the things step by step. So, okay. So that's I simply open my code editor. And before that, we previous day we also downloaded the tip image of the Iraq NDVI. In this time, I also try to show you that how you can easily work with this NDVI image in ArcMap software. So here I already opened the ArcMap software. ArcMap software. In this time, I also simply import the tip image of the Iraq NDVI. So this is my image NDVI year of 2021 of Iraq. Just I simply import the image in here. Okay, so now you can see it will be imported. Okay, but it's not the imported the properly. Why? Okay, we'll try to check the later. What's the problem for the importing? Okay, so in this time for filtering, so in this time I simply go to the browse data catalog and then click on the Sentinel. So here I can get all of the Sentinel image collection. You can see all of. Okay, so in this time I want to use this data set for Sentinel-2. Simply click on here. Then I can get all of the image collection for Sentinel-2, top up atmospheric, surface reflectance I can get. Or if you want, you can simply search here. Simply search Sentinel-2. And here you can see multi-spectral instrument Sentinel-2. I want to use this image. Simply click on here. And here I can get all of the information about this Sentinel-2 image collection. And also you can get all of the things. You can see all of the band we can get in here. Also you can get the image properties. Okay, so in this time I just simply import. You can see this, the import. So simply click on the import. Now this image collection is imported in my code editor. Okay, so now this is the image collection is the default variable name. If you want, you can change it. There is no problem. So just I simply put this name, suppose Sentinel-2. You can use any name. There is no problem. Now I want to check how many images are available for the Sentinel-2 for the whole world. Just I simply use here the print and call the Sentinel-2, because this variable is stored all of the image collection, and use here the size function. Then click to the run. So now it displays the result, how many images are available for the whole world between the time period year of 2015 0623 from present time. How many images are available? We can easily get in here. Okay, so now with computing we can get the very large number of image collection. From this large number of image collection, I need to filter it for my region. Same process. So just I simply import the shape file. Suppose I need this result for the Dhaka city boundary or Dhaka city shape file. I need a satellite image. I simply import the boundary and then put here, suppose ROI. You can use any name in here. So first of all, I take a variable. Suppose this variable name is the image. Suppose dry season. Suppose in this time I need the dry season image. So you can use any variable name. I simply use the image dry and call my collection Sentinel 2 and use the filter bounds function. Filter bounds with my region of interest ROI. After that, I just simply use a function such as filter date function. In this filter date function, I simply import start date and end date, such as year of 2020, suppose 1st January, from dry season period year of 2020 04, suppose 30. So this template simply select and then use here the filter metadata and put here the name, operator, and value. So name is the image properties name. I can get the image properties name from here, image properties. I use here the cloud pixel percentage and put this name in here. Then operator, such as I put here the less than, and set the value for 1. So in this time I can get only for this image, which image will be not more than 1% cloud cover for my region of interest in Dhaka city. So now I want to check how many images I want to get. So now it displays the result. We can get the 20 images for the Dhaka city, and this 20 images is the less than 1% cloud cover for this time period. Okay, so in this time, here total 20 images I want to use and make the median composite. So I simply use the median, and finally it's clip with my shapefile is that ROI. Okay, so now I display the result. For simply use the map dot add layer, call the image dry and click to the run. You can see one layer will be added in here, but I did not see the result. So for I simply use a function map dot center object, and object is that ROI and center focus 10 and click to the run. So now it focus the center of the Dhaka city, and I can easily get the result. You can see I can get this map look like this because I did not add the visualization. In this time I add the visualization in here. For visualization I simply click on here and set such as before red, then green and blue band, and custom 98%. And then apply. Okay, so now I can get the image look like this. Okay, so in this time, suppose I need the another time period image for the rainy season. Okay, for that I simply copy the same code from here and paste, and just simply change the variable name, suppose image wet season or rainy season, and also change the time period such as 06 from October, and also copy and paste. And I also import this and simply copy this variable name and paste after the object name is that I paste here this, and click the run. Okay, so I can get the result look like this. There are the two layer. First layer is that wet season and dry season. So in this time I want to add the color also in the wet season. Simply click on here and put this suppose B4, B3 and B2 and 8% and apply. And also import this visualization. Simply copy and paste after the object name. I also put the layer name. Suppose this is the wet or rainy season image, or this is the another, this is a dry season image. Okay, so I can get the two time period image. You can see and this is Sentinel-2 satellite images for the dry season. Mainly dry season, we can find out the very clear satellite images. There is the no cloud or haze. But rainy season, you can see, I can get the image look like this. Here we can find out the some cloud. Okay, so this type of cloud pixel we can easily get for the rainy season. But in Google Earth Engine platform, we can easily remove all of the cloud and haze from the satellite images and get the very clear satellite images. Okay, so mainly this cloud is hampered when you want to make the land use land cover classification map. So this cloud pixel value will be mixing with the build up or barren land pixel value and then destroy your land use land cover classification map. So this is the main condition when you want to make the land use land cover classification map. You must be remove this type of cloud. This type of cloud you must be remove and then make the land use land cover classification map. Then you can get the better result. But we mainly get the cloud for the rainy season. But dry season you can see there is a very clear satellite image we can get. Okay, and when you want to use this satellite images, there is a no problem for making the land use land cover classification map. We can easily create it, and we can also get the very better result using these satellite images because it's very clear. Okay, and if you want to export these satellite images, the same process which I already show you that. First of all, you have to select the band in here. You can simply select the band such as this image created the three band. This three band is that you can see B4, B3 and B2. We have to select this band. Use here the select function and put here the B4 band name, then B3 and also put here the B2. Okay, and then use the same function which I already show you the previous class, and then click to the run. We can easily export this satellite images also and open the satellite images in ArcMap software and also work for the further analysis. Okay. So you must be select the band name which band created this image. So in this time I want to export this image. So that's why I need to must be select which band created this image and then finally export the same function. Okay, so I can get the image look like this. In this time, I want to calculate the what is the condition of the NDWI or water index or surface on the water for different two time period, rainy season and wet season. So mainly rainy season, we can easily find out that lot of cloud, and also in the rainy season, we can also get the lot of water pixel value on the surface than dry season. Okay, so dry season we can get very permanent water, some permanent water body. But when I want to open the dry rainy season NDWI map, so here I can get a lot of water pixel value for the rainfall. Okay, so let's go. We observe that part using this NDWI. So first of all, we have to know about the NDWI formula. So what is the NDWI formula? NDWI formula is that I write the formula. Suppose NDWI is that I can put the formula green minus near infrared band divided by green plus near infrared band. So basically, this is the formula for NDWI. If you want to check it from the Google, just simply search here NDWI formula for Landsat. We can get this result. You can see band 3 minus band 5 divided by band 3 plus band 5. So, okay. Okay. So you can see NDWI formula is that green minus near infrared divided by green plus near infrared. So in this time I use this formula and then try to identify the water pixel value on the surface. Okay, so green minus near divided by green plus near infrared band. So I already write the formula in here. So now I just try to calculate it, this green minus near. So for that I simply take a variable, suppose NDWI dry. So when I want to calculate it, the NDWI for the dry season, so first of all, I can simply call the dry season image. So I simply copy this variable name because this variable is stored this dry season image. Okay, and paste here. And then use a function, this function called normalized difference. Okay, normalized difference is a built-in function. So mainly when I want to use the normalized difference, it automatically calculated this equation. Just I need to put here the band, which band I want to use. So in this time I use here the band green band is that B3, and near infrared band is the B5 for sentinel imagery. You can easily check it from here. You can see the band B3 is the green, and sorry, B8 is the near infrared. Okay, it will be B8. So B3 and B8. So just I simply put here the B8 because this is the near infrared band is the B8. Okay, so I simply call this image for the dry season and then apply the normalized difference B3 and B8. Then it automatically calculated B3 minus B8 divided by B3 plus B8 and calculated the NWI. Okay, and do for the same thing for the wet season. Simply copy the same code and paste. And when you want to calculate it the wet season NWI, then I simply call the wet season image. So you can see this is the dry season image. I call the wet season image is that image wet. Simply copy and paste here. Okay, so now it calculated the wet season NWI. Now display the result. So simply use here the map dot add layer and call the NWI dry and paste, and also add the map dot add layer and also call the NWI wet season and click to the run. So now I can say I can get the total 4 layer. Okay, I can get this map for NWI, but there is a no color because I did not use the any visualization. Okay, so in this time I need to apply the color so that I can easily find out the water pixel value. For that, I simply use here the curly bracket and put here the mean pixel value of stat -1, mean set from the -1, and max up to 0.5, and also put here the color plated such as red, then put here the yellow, then green, then blue, and also put the layer name. Suppose this is the NDWI dry season. Okay, and also call the same code. I simply copy from here, simply copy and paste. Okay, then click to the run. So now we can easily get the visualization of water pixel value on the surface.
Excuse me, Doctor.
Yeah, please.
About the cloud and the rainy season, how you
Yeah.
can exclude this cloud?
Okay, so we can easily remove the cloud from the Google Earth Engine platform. And next class, I also try to show you that how it will be work for the removing the cloud. So mainly cloud is hampered only for the land use land cover classification map. But when you want to work for the different types of indices, then this cloud is not hampered. Okay, cloud is only hampered for land use land cover classification. But when you want to make the NDVI map, NDWI map, or other types of indices, there is the no problem. Okay, so I also
Just
try
for
to show
land
you.
use land cover, LULC, just
Yeah, yeah. For LULC, it will be hampered
Okay, okay, thank you.
for the cloud. Other analysis is not problem. So in this time we can get the images. We can easily identify this is the image for the wet season. Okay, this is the wet season in AWI and this is the dry season. You can see this is the wet season. You can get lot of cloud, lot of water pixel. You can see lot of water pixel we can get. But okay, I also change the name such as we use the same name. So I put this layer name. This is layer name is for is the AWI wet season and click to the run. So you can easily find out understand about that. So these are satellite images for the dry season, and these are satellite images for the wet season or rainy season. And then we can get the NWI for the dry season or summer season. And then finally we can get the image for you can see rainy season NWI. So you can see the difference between these two things. So we can get the lot of water pixel value in the rainy season for the rainfall. But dry season you can see we can this is dry season in WI map. There is a very little water body we can get in here. But when I want to open the wet season or rainy season image, you can get lot of water pixel we can get. Okay, so you can see there is a no water pixel value for the dry season. But when I open this, I can get this water pixel value in this. Also for this side, also for this side. Okay, so this is the process how we can easily monitor the NDWI over a different time period. So summer season there is the no rain, so that's why I can get the result look like this. And wet season or rainy season there is the rain fall, so that's why I can get the result look like this. So now this is the map, and this map you can easily export in your Google Drive. And finally you can also create the map for your research paper look like this. Okay, so you can see this is the map, and this map we can create it from the Google Earth Engine platform. And then final create the map layout or other things we can use here the ArcMap software for representation our research paper or our presentation work for NWI map. So this is the process you can easily apply, and then you can easily monitor the NWI. NWI is mainly work for the ground surface. It not go to the ground level. So it's a upper on the surface. It only for work. So you can see, and you can easily make this an map. I also try to show you later how you can easily create this map in ArcMap software for using the TP images. So mainly when you want to export this image, we can get only for the TP image. Okay. Okay. In this time, if any question, any
No, thank
question?
you. No, no,
Okay.
thank you very much.
Okay.
It's clear.
And not only for the NDWI. Suppose you want to observe the NDVI. So NDVI is the normalized difference vegetation index. Just you can put here the NDVI formula. Suppose I want to calculate the NDVI. You can see what is the NDVI formula is that near infrared and red infrared. Near and red. So just you can simply put here the near. Near is that B8 and red is that B4. Okay, I simply change that. Suppose B8 and B4. Okay, and then put here the color plated. I simply change the color plated such as I simply change the color plated such as put here this blue color, then white color, and put here the green color, and also put here this blue color, then white color, and put here this green color. Now I can easily use the same code and also observe the what is the condition of the vegetation for the different season, and also put here the suppose one and click to the run again. So now it display the result for NDVI or vegetation index.
Excuse me.
Yeah, please.
How can I know how many indices for each satellite, or which index that I can use it for example for Landsat satellite, for example? Okay.
How many indices?
Yeah.
Okay, so there are a lot of indices are available. Okay, suppose and every individual indices have give you the information for every individual feature. Suppose you can see these indices for the NDVI. From the NDVI, we can get the result for NDVI. Where the vegetation is the high, where the vegetation low, we can easily identify using these indices. Okay, so other indices also have these indices we can use for monitoring. You can see in this time for the rainy season, we can get the lot of vegetation. Vegetation will be increasing in the rainy season. Okay, but you can see dry season and this is the rainy season. Rainy season vegetation is growth is the very well for the rainfall. But when I want to open this dry season, you can see then we can get this result look like this. Is a difference between the two time period vegetation. So indices, lot of indices will be available. Suppose NDVI, it mainly work for the vegetation. Then NDBI, it mainly work for the build up index. Then NDWI, it's mainly work for the water index. And every index or indices has a some formula. Suppose this type of formula. This type of formula you can see this type of formula. When you want to apply this formula, we can easily identify this feature. So lot of equation, lot of things will be available for the different types of indices. Well, for the different types of purpose, we can use here the different types of formula, and we can easily get the result. Suppose you can ZCI for index. This is the near divided green d minus one. So there are a lot of equation will be available for the we are using here the lot of equation for identify the water body. Okay, we are using here the lot of equation for identify the vegetation, lot of equation for identify the build up index, lot of equation for the barren land index, snow index. So lot of indices, a lot of equation is available. So which you want to need, simply put this equation and you can easily get this result about this formula. So here you can see NDII index, also you can see NDBI index, MNDWI index. So in this time, I just try to learn you what the process for calculating this type of equation. So further, when you want to need this any types of equation, you can apply the same process and you can easily get this type of map, this type of feature you can easily identify. Okay, so there is a no limitation for the indices. Every indices has a provide you the every specific information. Suppose this indices when I want to use at the NDVA indices such as a near infrared minus red, then I can get the vegetation. When I want to use at the green minus near infrared, then I can get the NDWI for water surface. Okay,
Yeah.
so different types of indices has a different types of provide you different types of information.
Okay. Okay, Doctor. I would just want to ask you another question
Yeah,
related to
please.
the same subject. For
Yeah.
example, if I want to calculate the NDVI, I can use, for example, Landsat satellite. I
Yeah.
can use the same index for another satellite.
Yeah, same index. There is no problem. Suppose in this time I use here the B8 and B4. B8 is the near infrared and red band. So B8 and B4 for the sentinel images. But when
Yeah.
you want to Landsat, you can see Landsat has another name for the near infrared and red infrared. So you can see for the Landsat, I simply open this top of atmospheric. You can go to the band. You can see for the Landsat, red infrared band is the B4. There is no problem B4, and near infrared band is the B5.
Okay.
Okay.
That mean all the indices can be applied for all satellites.
Yeah.
Okay. Thank you very
Just we
much.
have to change the band name because
Yeah. Yeah. Yeah.
uh
According
yeah
to each
B,
satellite,
yeah
bounded. Yeah.
yeah well,
Bounded.
yeah. And we can easily get this result for different indices and different feature. Okay. So I also send you this code. You also practice and also face any problem. We also try to discuss. Okay. So in this time, I simply go to my next slide. Okay. So now we can try to discuss about that how we can easily calculate any types of equation. So in this time, you can see this type of equation we can get only for the two band. But when you can see, suppose EVI index formula, you can see this formula is look like this. EVI formula is that this is the EVI formula, very big equation. So this type of equation has some constant value, also some variable. So when you want to get this type of equation, how you can easily handle. So in this time, I also try to discuss about that. You can see this is the EVI formula, enhanced resolution index, and this formula you can see 2.5 multiply with band 5 minus band 4 divided by band 5 plus 6 constant value multiply with band 4 minus 7.5 multiply with band 2 and plus 1. So this is the formula, and you can see this formula is the lot of combination, constant value, variable. So this type of formula, how we can easily calculate it and also get the result. So in this time, I also try to show you this part, how you can easily do that. So for that, I can simply open a new code editor.